Mark Spitz, Michael Phelps. 1972, Munich, I think, Olympics. I think it was in Munich that year. 7 gold medals, individual gold medals in swimming. Michael Phelps, 2008, China maybe, in 2008, I can't remember. China, thank you. 8 individual gold medals in swimming. Who is the more impressive Olympic swimmer? And why? Who is the more impressive Olympic swimmer and why? Aaron, please!
Depends on what, like, their actual speeds were and who they were running.
Oh, good for you. I got that, brother. I got that. So Aaron says, you know what? The point of this, I love this picture, by the way. So this was, Mark Spitz was notorious for self-promotion. Genius. I think the first, like, professional swimmer that self-promoted himself. He wins 7 gold medals. He knows he's a badass. Look at that face. I'm a badass. I got a stash. I got a hair helmet. So Phelps replicated the picture 30 years later, which I thought was genius. And the idea was, I got 8, he got 7. But that doesn't matter, right? That doesn't matter. What matters is how they had apples-apples comparisons. And there are tons of apples-oranges comparisons between 1972 and 2008, weren't there? Give me one difference between 72 and 2008.
The knowledge thing.
The training, yes, Anna, you got it. They learned so much more knowledge of the physiology of swimming. You ever seen butterflyers do butterfly in a pool competitively now? They stay underwater a scary long period of time now because they've discovered that you're actually faster underwater doing a dolphin undulation than on top of the water. As a matter of fact, they make them come up. If you stay underwater too long, you're DQ'd. They didn't know that in 72. Butterfly popped up and started butterflying. And the times have fallen as a result of that. Should we penalize Spitz for that? No, we should normalize the data for that. Thank you, Aaron. Give me another reason. Something else has changed in 30 years. Linda?
Material they use in their suits.
Those crazy shark suits that they wear. Some of them have been outlawed now. Some of the full body ones have been outlawed. Like the guys can only wear the ones that go down. Spitz wears, you can't see it in this picture, but Spitz wears a little tiny Speedo. Phelps didn't, I think he wore like either the full suit or the legs that are faster than skin, right? They simulate shark skin. Should we penalize Spitz for not having shark skin suits? No, we should normalize the data to not allow for that to be an influencing factor. So you guys have nailed 2 very important, not to mention drag in the water, for God's sake, right? So, Aaron, as per your request, now this is the gold medal heat, and it turns out these guys have 3 races they both gold medaled in. 200-meter butterfly, 100-meter butterfly, and I think the 100 free. I've got all the data in here. So this is just the 200-meter butterfly final meet. So per Aaron's request, this is the final meet in 72. This is the final meet in 2008. Can you tell by looking at these 2 meets who is the most impressive swimmer between Spitz and Phelps? Give me some things that jump out at you as you look at the data.
Spitz.
Spitz, why?
Because the time difference between the other people.
That is something, I'm glad you noticed that so quickly, Lloyd. It took me about 5-10 minutes and I'm like, holy crap. Now, 3/100ths of a minute doesn't seem like much. These are minutes. 3/100ths of a minute doesn't seem like much. In a race like this, when they're Evan rooting through the water, that's an eternity. As evidenced over here, look how close Phelps and Laszlo are. Very close, very close. Spitz basically destroyed second place, essentially. That's very indicative of a... But how about his time was still slower than the 8th place guy's time in 2008? Contest me, contest me. Contest me. Why should I not worry about that necessarily?
All of them were legit.
All of them are lower. The training, the wetsuit, the 30 years of practice, yes. If I asked you to quantify how much better Spitz was than Phelps, how could you do it? Because it's hard, right? His time is lower. So we can't look at times, can we? Times become an issue, but that's all I have here is times, right? Linda.
How much faster he was than the average?
Say that again.
How much faster he was than the average?
Yes! So what I've done is I've calculated the average of all 8 of these guys and their standard deviation, because I don't want to ignore that based on what you were saying earlier, Linda. Based on what you were saying earlier. I don't want to ignore this. Here's Phelps. Here's the average of his group and the standard deviation of his group. Now notice the average is higher in 1972 than in 2008, but that's to be expected. The standard deviations, it's lower in 2008. I don't think it's crazy lower, but it's definitely lower. It's lower by about 1/100th of a second, or 100th of a minute. which again, over a fast race like this could be meaningful, but it needs to be paid attention to. You can't just say, okay, so Spitz is 2:0:12, 2:06. That's a 0.05 minute difference, right? 0.05 minutes. Phelps is 1:86, 1:89. That's less than a difference. Well, but less than a difference ignores what a difference actually is. 1 minute is not 1 minute. Remember I talked about Max, how he perceives time differently than I do? That's because of the measure of variance in our ages. So we have to somehow tie this number into that too, the plus or minus. For example, how tall am I? I'm 3. 3 what? 3 what, right? You have to know what the what is. 3 what's taller. So you have to specify what the increment on the measurement you're using as, when you say he's further below average, measure further. You can't use the same stick for Phelps as you do for Spitz because the stick is a different measurements because of the different years. Does that make sense? So what you were doing earlier is exactly the computation you need to do. Here's what I've done it for you here. What we can do is we can convert their times into z-scores and then put them both on the same curve. Here they go, here they go. For Mark Spitz, turning him into a z-score, I look at his time versus the average. He's below, right? But then I divide that by the standard deviation, and that, number one, takes the time off, but also puts us on the same measurement scale as our 0 bell curve over there. So he is at negative 2.01. So Spitz is down here. Technically, he's in the bottom 5% of that bell curve. That's pretty low down, right? He's what you call an outlier, yes?
Yeah.
Michael Phelps, same move. 1.867 minus 1.898, yes? Good so far? Divide by his standard deviation, now they're both using the same ruler. Up till this point, they were using 2 different rulers, and you can't really compare. I'm 2, I'm 6, I'm bigger. But that doesn't make any sense until you know what the ruler's actually telling you. Now they're on the same ruler, which means Phelps is negative 1.62. Why are they negative?
Because they're the outlier
On which end?
to
To the left of 0,
Yeah, to
which
the-
means they're below
average.
average. Right, negative z-scores just mean below average. Negative z-scores in a swimming race mean you're doing well.
Yeah.
Right? You're in the top 4, most likely. The top 4 finishers. So, in other words, Spitz is more negative than Phelps is. So who's got my vote for more impressive swimmer? Spitz. He's more negative, he's further left, he's more impressive because he got further away from the average. It's measuring further away from the average, but using the same scale to measure it, Lynn. Does that make sense? Without dividing by the standard deviation, you can't call the difference meaningful. Same reason when Congress goes, well, the unemployment rate was 7.6%, now it's 7.4%, it's dropping precipitously. I don't know you can say that unless you tell me what precipitous means. Is a change of 0.2% precipitous? Well, it depends. What's the margin of error, right? The margin of error is the ruler. If the margin of error is 1%, and you've moved 0.2%, I tell Congress to go back and waste more money and stop printing erroneous headlines like that. But if the margin of error is 0.01% and it's moved 2 percentage points, you've moved a lot of standard deviations to make that up. That means we're jumping on that curve from 0 to 1 to 2 to 3. That's big movement, yeah? So Spitz is further down movement-wise than Phelps is. So my vote is Spitz is the better 200-meter butterfly. You can contest that, of course, and say that Phelps is for your own reasons. That's totally fine. I got no problem with that. I did the same thing for the 100 fly and the 200 free, which were the other 2 events they both medaled in. 100 fly, Spitz's z-score was negative 1.68. Phelps's was negative 1.4. Once again, I call Spitz as more impressive because he's slightly more negative, although he's not quite as impressive as he was in the previous race. I think maybe he was an endurance butterflyer, which is kind of like a contradiction in terms. Endurance butterfly. I do 25 meters of butterfly, I want to die. 200 free though, look what happens to 200 free. Spitz is 1.34, negative 1.34. Phelps is negative 1.92. He's got my vote for best freestyler, best 200 meter freestyler. If you've seen the guy, you know he's like 7'6". His feet are this big, his hands are this big. He paddles through the water like a freaking seal. It's pretty amazing to watch. Pretty amazing. I mean, and you think about this. Also, think about this. Do we have any swimmers in here? Got a couple swimmers? No swimmers. Anybody tried to do butterfly before? Okay, so you try. Realize that a 2-minute 200 meter means they're averaging 15 seconds per 25 length. I'm lucky to get down in 30 doing 25. And I'm not sure I could finish this in 4 minutes, even doubling my time, without my heart exploding. I do 50, I'm like, check please. They call it my Tyson moment. Whenever my coach makes me do more than 50, I get done to 50 and I lean up against the ropes like a boxer who's got the piss beat out of him. And I'm hanging on the ropes, just like, sucking the pull. When I come in here squeaky, I did it on the butterfly drills that day. Yeah, okay, good. Now how can we apply this to our IQ? Well, you do the same exact thing. This is the formula. This is the beautiful formula. This is it. You take whatever raw score you have and you normalize it by subtracting the average. Linda, you nailed that part. That was perfect, sister. Thank you for that. Figure out how different the score is from average. But then you gotta give it a ruler to measure it with. And the ruler is this little guy right here. This is why I always get upset when people learn about averages when they're in like 4th grade. But they never learn the corresponding standard deviation. They go through most of their lives until they get here, not understanding how important it is to measure that chance variation. And this is probably the most important way of measuring it. This tells you whether or not this difference is significant. This difference might not be significant at all. This will tell you if it is, by how big or how small it is. But the only way this can tell you if that's significant is based on the value of this. Is based on the value of that, yes. You're not as excited as I am, that's okay. It's totally fine. I don't take it personal. Okay, totally get it. It's also Tuesday before Thanksgiving. And that too. Let's finish up the IQ problem, get you guys the hell out of here. Let's finish up that IQ problem. This will be posted for you too. Please, Anna.
Who came up with this?
That's a damn good question. The history is a little bit cloudy. De Moivre was the one that actually developed the curve itself. It's debateful, it's questionable whether or not he developed the standard normal curve or just the general normal curve. What we're doing today is learning how to deal with any normal curve, which I call general normal, of which the standard normal is just one of many of those. So I'm going to say De Moivre and then Gauss fine-tuned it. So Abraham De Moivre was a French mathematician, Carl Friedrich Gauss was a German mathematician, late 17, early 1800s, somewhere in there. De Moivre came over before. Yeah, when you think about that, right? Think about it, late 1700s.
Why were they even thinking about that?
Dude, now you have to understand what mathematicians... You guys like music. You guys like music, right? Y'all probably all different kinds of bands, different kind of music you listen to. Me too, totally. You know how you feel when you hear like one of your favorite songs? Makes you tap, makes you smile, makes you happy. When we get infected with fun math problems, we feel the same way. I still feel that way listening to the Bouncing Souls. But I also feel that way when I realize the half, the fourth, the eighth is going to be a good way to explain that to you guys. Same exact like fuzzy feelings. I don't know what part of the brain or what part of the endorphins kick off that do that. So, Johnny, I don't have a good answer for you, except it's like any other puzzle. Why do we play the little games on our phones? Why do you play 2 dots, or 4 picks 1 word, or Angry Birds? I don't know if that's popular anymore, but why do you play these things? It engages a part of your brain, right? It engages a part of your brain that's, well, but it is, but it's not, because your brain's engaged, right? Right, it's giving you some kind of a center of your brain is firing, in much the same way other things that are doable are. Mathematicians just fell into these things. They started observing that in certain populations, stuff clustered near the average and tailed off predictably. And they just kept seeing it more and more and more and said, I wonder if we can generalize this behavior. And that's where it comes from. It's just, I wonder if, and then you just chase it down. It's not a very satisfactory answer. But please,
No,
Jay, go ahead.
I just want to know the name of the character that we're dividing by this.
Oh, that's sigma. That's lowercase sigma. That's the population standard deviation. Thank you, sir. So here's your population average, Jay. Population standard deviation. The reason we're calling it that is, for these problems, we're dealing with an entire known set of values. So we know the average IQ is 100 plus or minus 15. Why? Because psychologists have told me that for years. I forget the name of the IQ test, the Wechsler, I think it's called, the Wechsler IQ test, has an average of 100 plus or minus 15. Why? Because they tell me. Okay, let's use it then. I mean, that's the best I can say. Linda, please.
So when we're working with Devin, it seems like the first thing we need to do is make sure that we have like figuring out what the average value is, calling it 0.
Yes, that's what we're about to do right now, is taking the orange scale and putting it on the black scale. Yes, ma'am, that is the first thing. He goes, so let's do it. First,